In this video, we're going to look at setting up a double integral using in both orders of integration, either with respect to x first and then with respect to y, or vice versa. So let's look at the double integral of 1 over 1 plus x squared, where the region that we're integrating over is the triangle with vertices 0, 0, 1, 1, and 0, 1. So here's what a graph looks like. Notice that we can integrate with respect to either variable first, though notice that this one, I mean, it's not a horrible integrand to do, a horrible integral to do with respect to x first, but it's maybe a little bit nicer to do this with respect to y first, because this function is a constant with respect to y first. So, but anyway, we're going to look at both orders of integration. So here's our integral with respect to y first. Well, if we want to do with respect to y first, y goes from y equals x to y equals 1, and then x's go from 0 to 1. So y equals x to y equals 1. We put the y on top. We get 1 over 1 plus x squared minus x over 1 plus x squared. Antiderivatives for each of those, we get an inverse tangent of x and a minus 1/2 natural log of 1 plus x squared. Plug in your endpoints and you get pi over 4 minus 1/2 natural log of 2. If I go the other way around, let me click back over. If I want to do with respect to x first, my x's go from 0 to y. So I get integral from 0 to 1, integral from 0 to y. Antiderivative for this is just 1 over 1 plus x squared. That's inverse tangent of x, evaluated from 0 to y. And so then we just get integral of inverse tangent of y. This cut off on the edge of my screen. I apologize for that. This is what you would have if you're doing, you have to do this by parts, right? This would be my u. My du would be 1 over y squared dy. I forgot my dv here would be dy. So my v would just be a y, which is off the slide. So I apologize. It would be off your screen. I apologize for that. But anyway, you can imagine that your v would be just a y. So you're going to do u times v, so that's where the y inverse tangent of y comes from. And then a v du, so that's where the y over 1 plus 1 y squared comes from. This is going to be evaluated at the endpoints, and I still need to integrate this according to our integration by parts formula. But again, this integral is just 1/2 natural log of 1 plus y squared. And now notice that we're going to end up with the same answer that we get as we did before. We're going to get the pi over 4 minus 1/2 natural log of 2.